Today we're going to look at a Seresco Natatorium dehumidification unit. Purpose of this unit is to provide dry air to a pool room area, to take some of the humid air out of the pool room, dehumidify it, as well as take some of that pool room air and eject it outside. At the same time, when we are dehumidifying or air conditioning, we can also heat the pool water, and then we've also got hot water coils in this. I'll show you, so we can also heat the air that we bring in from the outside, and also just heat the pool room area in general. So this is inside of our supply air chamber. We've got two direct drive forward inclined blowers that are going to pressurize this chamber, send it out through this duct, which is feeding two perimeter duct socks around the whole pool room area. Duct socks are becoming pretty popular in the natatorium areas because they're good distribution abilities. The expense, they're not incredibly expensive, and non-corrosive. In this chamber we also got two receivers, because we do have two different refrigeration circuits in here. These receivers have a sight glass at the lower and at the upper portion of it, where we have a little ball float. The manufacturer actually uses these to verify charge a little bit, that the lower half ball should be floating, the upper half ball should not be floating, and if our head pressures are in reasonable range and under full load in the air conditioning mode, you have a pretty good idea that you're going to have a decent charge in it. Of course, verifying superheat and subcooling, although that's can be pretty difficult in these units. Okay, so we'll come around here to our compressor area. It's nice having a compressor area that is, one, located inside, and two, not in the airstream, so we can access these compressors and our controls up here while the unit's running. So we got two semi-hermetic compressors. For each refrigerant circuit, we have two coaxial heat exchangers that at any time the pool water is below its set point, which we could set on our controller up here. Instead of rejecting that heat outside, we're going to recoup some of that heat, and we're going to heat the pool water with the high side of the system. So each circuit can do that. Okay, in this section here, here's the inlet to our blowers. So two separate blowers. This one actually had a problem where one of the blower wheels had come off the shaft and kind of self-destructed. So we're in the process of ordering and replacing one of those. This is our hot water coil. We do have regular water in this coil running throughout this. This coil is for air heating, and the heat is being provided by a boiler in the other room, and with just regular water in there, no freeze protection. We do have to be careful with this unit as we're bringing in outside air, that it stays within a reasonable temperature range so we don't freeze and break this coil, and that does happen. Okay, at any time that we need to dehumidify the air, we keep pretty high humidity set point, but it has to be controlled. Typically we're going to be above 50% and usually below 55, certainly below 60%. So 53, 54% is pretty typical. But anytime that we have to dehumidify, but we do not need to cool the space, because we do not want to overcool the space where people coming out of the pool are going to feel cold. So typically we're going to keep our pool water maybe only about 2 degrees cooler than the air temp. So if we got an 80-degree pool water, we're going to have it as high as 82 degrees in the pool area, and that's pretty typical. You usually don't realize that the pool areas are that warm because you do need it to be that warm so when you're coming out of the pool you're not cold. So on the other side of the hot water coil, we have a reheat coil. So if we need to dehumidify, but we do not need to cool the space, we're going to send some of that hot gas into this coil here. So as our evaporators cool the air, say down to 55 degrees, we're going to send high side, our condenser refrigerant, into this reheat coil, and we're going to reheat that air. So right here we cool the air down to 55 degrees or so, and then these coils are going to reheat that air back up above 80 degrees. So then as we finally come out of our unit, we're going to have a 80, 88, 90 degree discharge air temperature, even though we are air conditioning in this portion here, so we can dehumidify that air. Okay, like I said, we bring in a lot of fresh air because that's a lot of what we want to do in the natatorium area is we want to do some air changes. So we're going to take a lot of air from outside and we're going to bring it in. And if we are pressurizing the space, we don't want to over pressurize the space. So then we're going to take, this is a relief fan. This is our duct that we're taking from the natatorium area. And as we start to over pressurize the pool area, we're then going to turn on this relief fan and we're going to forcibly eject that air outside. And that's where we're sending our air right back up outside. So we're bringing fresh air in, it's going to pressurize the space, and our relief fan is going to relieve that pressure mechanically by forcing it outside. So we talked just a little bit about our air heat coil with water in it, supplied by our boiler, which is in this room. So this boiler is doing a couple things. It is providing heat to hot water coils and different air handlers throughout the building. But then we're also sending that to a hot water to pool water heat exchanger. So we got our heat exchanger here in one circuit, the one with the Schedule 80 PVC pipe there has pool water going through it. Then on the other side here with the steel pipe, we've got our boiler water going through it. So this boiler water never directly mixes with the pool water. We do that through the heat exchanger, but we do send this hot water through this piping here, which is going to feed that hot water coil in the Seresco unit.